Now for problem 33, we have let y equals f of x equals 2 times the square root of x minus 5. Find f inverse of y and the domain and range of f inverse of y. So I guess here, first thing is going to be set y equal to, there we go, y equals 2 square root x minus 5. And we want to get that x on its own. So my first step is just going to do 5 by 2. Y over 2 equals the square root of x minus 5. To get rid of that square root, we want to square everything. So we have y squared over 4 equals x minus 5. And then we end up with, finally, y squared over 4 plus 5 is equal to x. Or f inverse of y equals 5 plus y squared over 4. Perfect. To find the domain and range, we're going to want to notice that the range of f inverse of y is equal to the domain of f of x. So our domain of f of x, if we look, really the big thing that's going to mess us up here is that x equals 5, or x minus 5. We cannot have the square root of a negative number, so we want to say, okay, well, x minus 5 greater than 0. That means x has to be greater than 5. So our range will be 5 up to infinity. Now infinity is unincluded, so let me rewrite this. It needs to be greater than or equal to 0. So x has to be greater than or equal to 5, which means that 5 will be included in the range. And for the domain, the opposite will be true. So the range, we'll want to determine the range of f of x. So if we look here, the lowest possible value we can get from our square root is 0. And 2 times 0 is 0. And every value above that is possible. So our domain is going to be from 0 up to positive infinity. Next, we have 1 hour before a football game, a sponsor gave away 5,000 special wristbands to the 10,000 people there at that time. If S is the number of people who arrived after the giveaway, then the function P equals f of S, 5,000 over 10,000 plus S, represents the ratio of the people with the special wristbands to people in the crowd. Find f of 2,000 and explain what it means in terms of people with special wristbands in the crowd. Round to 4 decimals. So what we want to do is say f of 2,000 is going to be equal to 5,000 over 10,000 plus 2,000, which is the same as 5,000 over 12,000, which is the same as 5 over 12, or approximately 0.4167. That means 41.67% of people have a special wristband. That is what that means. Now, we want to find f inverse of p, which would be, if we set p equal to 5,000 over 10,000 plus s, we want to isolate that s. So, kind of similar to earlier, our first step is going to be to multiply this denominator over. So we have P 10,000 plus S is equal to 5,000. Go ahead and distribute out that P. So we have 10,000 P plus PS equals 5,000. We can say from there PS is equal to 5,000 minus 10,000 P, or S is equal to 5,000 minus 10,000 P over P. And S now is the same as F inverse of P. Finally, we want to evaluate F inverse of 0.35 and explain its meaning in terms of people with special wristbands in the crowd. We want to round to a whole number, just since our output is going to be in units of people. So F inverse of 0.35 is equal to 5,000 minus 10,000 times 0.35 divided by 0.35. That's the same as 5,000 minus 3,500 over 0.35, which is 1,500 over 0.35, which gives us 4,285.7, or 4,286 people. This means that S, the number of people who arrived after the giveaway, so that means once 4,286 people arrived after the giveaway, 35% of people had a special wristband. Okay, so for question 35, we have that functions f and g are given below, so we want to find each of the following. So first, we have f of g 0. So looking at our graph, we tell, okay, g of 0 appears 1, so that means that f g of 0 same as f of 1, just because this whole value is equal to 1. Now f of 1, that from our graph is equal to 2. So we know that that is the answer to 35A. Perfect. Nice and easy. Now for B, this one gets a little bit trickier, but just bear with me. So first we have f inverse of 5, which means that we're going to find an output of 5, determine what input would get there. So g of f inverse of 5 is the same as g of -1. Now looking at our graph, g of -1 is over here. That is equal to 0. Again, nice and easy. Now for 36, we want to use the graphs of f and g to find each of the following. So first, we have g of f of x is equal to 3. Solve for x. So g of f of x is equal to 3. In order to find that, what I'm going to do is I'm just going to draw on the graph and determine when is g3. So g of f of x is equal to 3, which is equal to g of 2. Which means that when we plug in 2g, we end up with 3. This means that f of x, our input function, has to be equal to 2. Now again, just going to kind of come over to our graph, carry 2 over, see where that intersects with our graph, then drop that down. It looks like that value, f of x is equal to at x equal to 8. Perfect. Now, next thing we want to do is find f inverse of, find f inverse of 3. So kind of like we did before, take my graph, find the 3, carry that over, drop down. So f inverse of 3 is 6. Now g inverse of 4, find the 4. Notice we can just carry that right down. That has a value of 0. Perfect. Now the next one looks a little bit trickier, but bear with me. It's not too bad. So first we want to find what is f inverse of 5. Now f inverse of 5, you can find if we find 5, drag that down, end up at x equals 2. So this, same as g of 2. Just looking back at our graph, is equal to 3. Awesome. And then finally we have g of 6 minus f of 6. So g of 6 is here at 1 minus f of 6 has a value of 3. So g of 6 minus f of 6 is the same as 1 minus 3, which is equal to -2. Perfect. Awesome.